Okay, so hello and welcome to this video tutorial for E411 statics and dynamics of simple mechanisms. Let me just move my face down here. Let's have a go at this problem then. Question 5, determine the tension developed in wires CA and CB required for equilibrium of the 10 kilogram cylinder, taking theta to be equal to 40 degrees. 40 degrees C, just 40 degrees. Okay, so let's start by drawing a simple free body diagram. I like it when Microsoft whiteboard gives me like a nice straight line. It automatically gives me a nice straight line. Sometimes it does it, sometimes it doesn't. There we go. So we've got this one here, and this one here, and this one here. Lovely stuff. Let's label up the geometry of this problem. So we can say that this angle here is 30 degrees, and it says theta equals 40. So we can say that this is 40 degrees. Let's label out my points as well. Why not? A, C, and B. Awesome. And we have this this force acting down. There's only one force here, and it is the weight of this cylinder here. And we can describe this as 10G. I'm trusting that you guys are familiar with this idea of gravitational, the gravitational constant, where G is equal to 9.8, or in this example, I'm gonna call it 9.8. Some people might go one step further and call it 9.81, and that's okay too. 9.8 meters per second squared. Okay. As you might typically do for simple problems like this, you might resolve vertically and horizontally. We understand that the system's in equilibrium, so we understand that the sum of the forces is equal to 0 in the x and in the y. So let's start off with the horizontal forces. Why not? So the horizontal component of this force, this tension force along CB. I said earlier that there was only one force acting here. I was completely wrong. There's of course these tension forces acting here. So the horizontal component of this force CB will be, let's call it CB cos 40. Minus, let's call it CA cos 30, and we understand that these sum to 0. Is this solvable? No, it's not, because there are two unknowns here. An equation is not solvable in its own right if there's two unknowns in it, so let's move on then and resolve vertically. Things moving up, we have CB sine 40, and we have CA sine 30, and we have this 10G force acting down. That's equal to 0. Okay, so we have two unknowns still, CB and CA. We know what G is, it's 9.8. And we have two independent equations. As I'll always say, if you have as many independent equations as you do unknowns, then the problem is solvable. So let's go ahead and solve it then. I'm going to label this equation here equation 1. Still getting used to this this writing pad that I've just bought. And I'm going to label this equation 2. Okay. Just looking at this, I would approach this by using substitution. So I'd probably rearrange equation 1 to the following. So I'd say that CB is equal to CA cos 30. So I've added that cos 30 to both sides, and then I've divided by this cos 40. Okay, so that's CB. I'm just going to just cut that off. Right. Okay, so I have CB in terms of CA. I'm then going to substitute it into equation 2. So I can say that CA cos 30 over cos 40 sine 40 plus CA sine 30 equals 10g. I'm just going to add 10g to both sides there. Okay, therefore CA, I'm just going to factorize here. One thing to take note of, don't have to do this, but we have what's called a trigonometric identity here, or an example of a trigonometric identity that you're always that can be quite helpful to spot when doing maths. It's this identity here, this idea that the tan of an angle is equal to the sine is always equal. So three lines there. Sine of an angle over cos of an angle. So here I'm just going to write cos 30 tan 40 plus sine 30. So I've just factorized there is equal to 10g. Therefore, CA is equal to 10g over this mighty bracket here. Let's just keep it in brackets for understandability, plus sine 30. You don't have to follow every single step or do this exactly as I've done here. You could, for example, have bunged this bracket into your calculator and it would have given you a number, which you could have then used. The way I tend to go about things is I like to write it all out and then I'd like to bung it in my calculator. So I've written it all out here, 10g over blah, 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 blah. I'm just going to bung that in my calculator now. So CA equals 10 times 9.8 all over cos 30 tan 40 plus sine 30 is all equal to 79.9. Yeah. 79.9. Newtons. And conveniently, we have CB in terms of CA written right there. So I can say, therefore, CB is equal to 79.9 times cos 30 all over cos 40, which I can then type into my calculator. 79.9 cos 30 all over cos 40, which gives me 90.3. Equals 90.3 newtons. Let's underline my answers and go back to the original question just to double check that it's all there. Determine the tension developed in CA and CB. Yeah, that's all it's asking. Okay, so that's how I tackle that problem. Any questions, feel free to leave them in the comments, and thank you very much for watching.